So my name is Nikhil Shetty. I work for the University of Wyoming as a data visualization specialist. So I'm appointed kind of in two different departments, which are kind of related. One is the School of Energy Resources, which houses the visualization facility, and in the Advanced Research Computing Center, which has the supercomputers. So I connect the supercomputing with the visualization facility. So my vision for the software kind of stems from the needs that we have in the university. So we have a high-performance supercomputing center, HPC center, and we have an advanced visualization facility. And then we have scientists and researchers who have very large data which they want to visualize in such kind of a facility. So there are advantages to kind of using the facility, and I want to be able to provide a very easy way to kind of use the facility, which currently we don't have very many tools to kind of do that. So I want to give researchers an opportunity to be inside the space and be able to work inside the space rather than outside of it, and leverage this to their advantage. Although we have a high-end visualization facility, today we see a lot of immersive technology coming in, which is very cheap and very accessible. And the Oculus Rift is one such technology. We want our software to also leverage such devices as well. And what we are currently seeing is a port of the same software on an Oculus Rift. So users can experience a very similar things that some of our scientists experience in the cave, but in a more personalized and much more cheaper device like the Oculus. The prototype that we've put together is an example of how immersive visualization can actually benefit in debugging and really help science and scientific endeavor using big data. What we have here is data from one of our researchers who looks at kind of tiny volumetric data of rocks in reservoirs, and they want to model kind of the same rock in a ball and stick model, so as to run some simulations on them. Now, traditionally they would create their own data set and try to match their qualitative results and go from there. But the researcher wanted a little bit more. For him, true science is not just looking at qualitative information, but also backing the qualitative information with quantitative analysis. So he wanted to match his ball and stick model with the actual scanned image of the rock, and in order to verify the model that he was creating. And he couldn't use any 2D desktop-based display to actually get into his rock and verify that, because of the complexity of the entire data set and the complexity of what he was doing. And so here we see an example where you're actually immersed in this space, and he came in at successive iterations, looking at his data set and debugging as he went along, making his code to develop the model. So we see kind of an isosurface extraction of the empty space inside the rock, and we want to see whether the ball kind of fits within that empty space so that it kind of mimics the entire model. What I'd like for people to take away from this is to look at immersive visualization as a workspace rather than just a display technology, where you can do active debugging of some of your code within the space in order to verify validate some of your work the way one of our researchers has done in this example. A big takeaway will be to reconsider immersive visualization facilities And VR facilities is more as a programming and a development environment than a pure projector-like display environment.